In this video, we are going to discuss the structure of interhalogen compounds. Now, first of all, structure of XY type of interhalogens, and the example is iodine monochloride. Now, here two halogens are there, iodine and chlorine. Electronic configuration of iodine is atomic number 53, krypton 4d10, 5s2 5p5, and the outer electronic configuration or valence shell electronic configuration for iodine is 5s2 5p5. It means there are 7 electrons in outermost shell. For chlorine, electronic configuration is atomic number 17, 1s2 2s2 2p6, 3s2 3p5, and valence shell electronic configuration is 3s2 3p5. In case of chlorine, again there are 7 electrons in outermost shell. So how at the time of writing structure, there are 4 steps. Step 1 is write the Lewis structure, Lewis dot structure for the compound. Find out total number of bonding pairs of electrons and non-bonding or lone pairs of electrons. Then determine the steric number. And steric number, it is the sum of bond pairs plus lone pairs, or it is the sum of bond pairs and lone pairs. So steric number, it is equal to bond pairs plus lone pairs. And next step is from the steric number, we find out the proper geometry or suitable geometry. If steric number is 2, then structure is linear. If steric number is 3, then triangular. If steric number is 4, then tetrahedral. If steric number is 5, then it is trigonal, bipyramidal, and so on. So in this way, this is the electronic configuration for iodine and chlorine. Now first of all, the Lewis dot structure for iodine monochloride is this one. So there is one bonding pair, and iodine is the central atom, and therefore there are 3 lone pairs. So number of bonding pairs equal to 1 and number of lone pairs equal to 3. At iodine there are 3 lone pairs and there is one bond pair, and the steric number is 1 plus 3, that is bond pair plus lone pair, it is equal to 4. And this is AbE3 type of molecule. E stands for lone pairs. There are 3 lone pairs. And for AbE3 type of molecule with steric number 4, expected geometry is tetrahedral. But here actually iodine occupies the center of the tetrahedron and one chlorine occupies one of the corner of tetrahedron, and remaining 3 corners of tetrahedron, these are occupied by 3 lone pairs. This is the expected geometry, but observed geometry is different, that is linear. There is only one bond and therefore this molecule is linear. Expected geometry is tetrahedral, observed geometry is linear. Alternative method is H is equal to half V plus M minus C plus A, where H is hybrid orbitals, or this is also analogous to the steric number. V is valence shell electrons of central atom, M is monovalent atoms, C is number of positive charges, A is number of negative charges. So here H is equal to half, valence electrons of iodine is 7, monovalent atom, actually chlorine is monovalent atom, it is attached to iodine, so it is 1. Positive charge is not there, negative charge is not there. This is chargeless molecule, there is no any positive or negative charge, and therefore 0, 0. So 7 plus 1, that is 8 by 2, that is 4. So H is equal to 4, it means it undergoes sp3 hybridization, and sp3 hybridization means expected geometry is tetrahedral, but as there is only one bond pair and 3 lone pairs, it is linear molecule. Whenever there is only one bond pair, the geometry will be linear. Okay, next molecule is XY3 type of interhalogen. Example is bromine trifluoride. Again, bromine and fluorine, outermost electronic configuration is same, NS2 NP5, and the Lewis structure is bromine is at the center, 3 fluorines are attached to bromine. There are 3 bond pairs, and at bromine there are 2 lone pairs. So number of bond pairs are 3, number of lone pairs are 2, number of lone pairs are 2, and the steric number is bond pairs plus lone pair, that is 3 plus 5, it is equal 3 plus 2, that is equal to 5, and it is a AB3E2 type of molecule. And when steric number is 5, the expected geometry is trigonal bipyramidal, where bromine is at the center and the horizontal positions of trigonal bipyramid, it is occupied by 3 fluorines, and lone pairs, these are occupying the vertical positions. Or bromine is at the center, these 2 lone pairs occupy the vertical corners. Or this is another possibility, bromine is at the center, out of 2 lone pairs, 1 lone pair occupy the vertical position and other occupy the horizontal position. So this is the expected geometry, that is trigonal bipyramidal, but the observed geometry is bent T-shaped, where 2 lone pairs occupies the horizontal position, and lone pair repulsion is more than lone pair bond pair repulsion, and therefore the vertical bromine fluorine bonds, they are bent like this. Because of this lone pair repulsion, the bond angle fluorine bromine fluorine, this bond angle, it is reduced. It is not 90 degree, but it is less than 90 degree, that is 87 degree, and therefore observed geometry is bent T-shaped. Again, alternative method is H is equal to half V plus M minus C plus A, half number of valence electrons of bromine, it is 7 plus 3, because 3 monovalent atoms, that is fluorine atoms, attached to bromine. So 7 plus 3, that is 10 by 2, that is equal to 5. So as H is equal to 5, steric number is 5, or number of hybrid orbitals are 5, and therefore bromine undergoes sp3 dehybridization, and for this hybridization characteristic geometry is trigonal bipyramidal. But as 3 fluorines are attached to bromine, bond pairs are 3 and lone pairs are 2, because 5 minus 3, that is equal to 2, and therefore lone pairs are 2, and expected geometry is different, that is trigonal bipyramidal, and observed geometry is different, bent T-shaped. Then next is XY5 type of interhalogen. Example is iodine pentafluoride. Again, this is the Lewis structure. Iodine is attached to 5 fluorine atoms. This is the Lewis structure. Here bond pairs are equal to 5. As there are 5 bonds, bond pairs are 5. Lone pair is 1. At central iodine atom there is 1 lone pair. Steric number is 5 plus 1, that is equal to 6. And this is B5E type of molecule, because there is only 1 lone pair. And as steric number is 6, expected geometry is octahedral. And this is the expected geometry. Iodine occupies the center of octahedron. Out of 6 corners of octahedron, 5 corners are occupied by the fluorine, and 1 corner it is occupied by the lone pair. But the observed geometry is square pyramidal, where 4 fluorine atoms occupy the base of square pyramid, and remaining 1 fluorine atom occupies the top position of the square pyramid. Alternative method, H is equal to half V plus M minus C plus A. This is equal to half. Number of valence electrons of iodine 7 and number of monovalent atoms attached to iodine equal to 5. Positive charges are 0, negative charges are 0. So 7 plus 5, that is 12, upon 2, that is 6. So H is equal to 6 means number of hybrid orbitals are equal to 6, and therefore hybridization is sp3d2, and for sp3d2 hybridization characteristic geometry is octahedral. This is the steric number also, but hybrid orbitals are 6, but number of bond pairs must be 5 because 5 fluorine atoms are attached to iodine. So bond pairs are 5 and 6 minus 5, that is equal to 1. So bond pair, lone pair must be 1. So bond pairs are 5, lone pair is equal to 1. So without drawing Lewis structure, we can find out bond pairs and lone pairs. Even we can know about the hybridization of central atom. And the last type of interhalogen compound, that is XY7 type of interhalogen compound, and the example is iodine heptafluoride. This is the Lewis structure. Iodine is at the center and it is attached to 7 fluorine atoms. So there are 7 bonds between iodine and each of the fluorine atom. So from this Lewis structure, it is clear that number of bond pairs are equal to 7. So 1, 2, 3, 4, 5, 6, 7. There are 7 bond pairs. And number of lone pairs at iodine equal to 0. All the electrons of iodine involved in the process of formation of bond, and therefore lone pairs are equal to 0. Steric number is 7 plus 0, that is equal to 7. So this is AB7 type of molecule, and for AB7 type of molecule, the expected geometry is pentagonal bipyramidal, where iodine is at the center and 7 fluorine atoms occupies the 7 corners of pentagonal bipyramid. So observed and expected geometry for this iodine heptafluoride is same. Alternative method, formula is H is equal to half V plus M minus C plus A. So H, that is number of hybrid orbitals, equal to half into 7 number of valence electrons present in iodine equal to 7 plus 7 monovalent atoms attached to iodine, it is equal to 7. So 7 plus 7, that is 14 by 2, that is 7. So it undergoes sp3d3 hybridization, which is the characteristic hybridization for pentagonal bipyramidal molecule. So as H is equal to 7 and 7 fluorine atoms are attached to iodine, number of bond pairs equal to 7 and lone pairs must be 0, that is 7 minus 7, that is equal to 0. So bond pairs are 7, lone pair is equal to 0. Such is the alternative method. So in this way, in this video we discussed about the structure of different interhalogen compounds, and here we completed the chemistry of group 17 elements.